Okay, so this is a quick little recap of all of the rules we've learned so far. There is one that we have not talked about, but I will go ahead and briefly talk about. The only thing about this chart is it doesn't go in the order that you should follow whenever you are simplifying exponent laws. So I'm going to actually go in the order that you should follow. So I'm going to jump around here. The first one you should look for, technically, this isn't 100% of the time, but there's only special cases, so it happens 99% of the time. The power rule. Okay, so the first rule that you need to look for to clean up is the power rule. The power rule says that when I have a set of parentheses raised to a power, I'm going to distribute that power to everything inside. So the rule is I'm going to multiply the exponents. So whatever the exponent is on the outside, I multiply it to all the exponents on the inside. So if I look at some examples, number 1, okay, I have 2 raised to the 3rd power. So a power raised to the power. So I'm going to distribute and then multiply. 3 times 2 is 6, so this ends up x to the 6. Now, whenever it comes to there being a coefficient, you have to remember that a coefficient has a power as well. That power is 1. And the reason why that's important is because when I distribute this 2, it's not negative 2 times 2, it's 2 times 1, which is 2. So this is negative 2 squared. And then m is 5 times 2 is 10, okay? And then I want to clean this up because I can't leave it like that. So negative 2 squared is positive 4m to the 10th, okay? Now, they try to trick me here. They introduced the product rule with it, which is technically the next step. But with the product rule, you're going to add the exponents of the same variable. So this is going to end up being 4. 10 plus 3 is 13, so m to the 13. Okay, so the first rule was the power rule. Then we look to the product rule. The product rule says that when I have the same base, I add my exponents. So this would be a plus b. So an example would be h squared times h to the 6 is 2 plus 6 is 8, so h to the 8th. Then number 2, this is just takes it a whole new level. All right, so the rule says that I'm going to multiply my coefficients. So that means negative 2 times 7 is negative 14. But I'm going to add my exponents. So a is 2 plus 3 is 5, and b, 1 plus 1 is 2. Okay, so I know it can be a little deceiving because the product rule, it makes you think that you're going to multiply everything. You only multiply the coefficients, but add your exponents. Now the third step after the power and product rule is looking for your quotient rule. Your quotient rule is like division. You're going to simplify your coefficients, but your exponents you're actually going to subtract. Okay, so if I look at number 1, what I mean by simplify my coefficients is 27 over 42 simplifies to 9 over 14. Okay, then I have x to the 5th over x, and you subtract. 5 minus 1 is 4, so x to the 4th. Number 2 has the power rule and the quotient rule. So remember the order. We have to take care of the power rule before the quotient rule. So my power rule says 2 times 2 is 4, so y to the 4th over y to the 4th. Now, at first you think, oh, those cancel, miss. My answer is 0. Well, to be honest, they don't. Because you have to think of it as 5 divided by 5, 10 divided by 10, 20 divided by 20. All of those equal 1. So there you go. Then we look to see if we can add and subtract. Adding and subtracting is like combining like terms. You have to have the same variables, the same exponents, they have to have the same last name. So if I look at number 1, the only reason I can subtract 9 and 10 is because they have x squared y, x squared y. So then I just read it from left to right. 9 minus 10 is negative 1. And then I keep the same last name. So it's just x squared y. Don't change anything. Then when it comes to word problem, subtract 6w from 8w. You have to be careful on the wording. So this isn't 6W minus 8W. It says subtract 6W from 8W. So it's actually in the reverse order. And the only reason I can subtract these two is because they have both W's. So 8 minus 6 is 2, and same last name, so 2W. Now, I want to introduce a new rule. This rule is kind of a floater. And the reason why I call it a floater is because it could pop up anywhere, and you have to just take it. It can pop up between the rules. It doesn't necessarily fall in the same order as these others. This is called our negative exponent rule, and we're going to talk about it more tomorrow or the next day, whatever comes after this. The rule of the negative exponent rule says that I can't have a negative exponent, okay? If I try, so I can't leave it a negative exponent. So to take care of a negative exponent, I have to change it to a positive. And the only way to change it to a positive is to move it. And the way you move it, and this is not a beautiful example, but the way you move it is if it's in the numerator, to make it positive, I'm going to move it to the denominator. That's all you do. So the same idea is, let me think. So, the same idea is if I have, I'm just going to make this up. If I have two, trying to think of a good example. If I have a negative exponent in the denominator, then I just move it to the numerator to make it positive. So that's what the rule entails. So if I look at number 1, now this only applies to negative exponents. I can have a negative coefficient. So if I look at number 1, negative 5 is still going to be negative 5. I'm not going to try and change that. But I can't have a negative exponent. So just to make a negative exponent a positive, I'm going to move it to the denominator. And notice, negative 5 stayed in the numerator, and x squared moved to the denominator to make it positive. That's all you do. Now, number 2, I teach this differently to avoid negative exponents. So this is where my trick kind of comes in handy. So this is the quotient rule right here. I'm going to show you both ways on this, by the way, okay? I'm going to show you my way first. So this is the quotient rule. 4 over 8 simplifies to 1/2. And then I tell my kids, I circle the higher power. So 5. 5 minus 2 is 3. And it ends up in the denominator because 5 was the higher power. This trick avoids that extra step of dealing with negative exponents. So let me show you the other way. So this is still the quotient rule, okay? 4 over 8 simplifies to 1/2. But how some others might teach it is they always just subtract 2 minus 5. But if you think about it, 2 minus 5 is negative 3, okay? Now, you can't leave it negative 3. So in order to make it positive, you have to end up moving it to the denominator to make it positive. So we end up with the same answer. It's just there's this extra step of dealing with negative. So it's kind of just one of those things that if you want to do a little shortcut or if you want to just know the steps, that's up to you. They're all end up with the same answer. So there's all the rules. We are going to learn another one, so be prepared.